Yahoo! Finally, the last question on chapter 8AE, question 13. What can we expect from this question? I don't know yet. Let's go. Alright, question 13. The population of kangaroo on an island is increasing at a rate given by P as a function of T equal to 12 log E bracket T plus 1 close bracket, where T is the number of years since 1st January 1955. Alright, so we got a population of kangaroo function over here. Oh, no, remember, this is a rate function. Right, it's a rate function. Okay. Oh, by the way, kangaroo. You know, I recently watched that movie, The Arrival. The Arrival movie. Alright, so it's, you know, I don't wanna spoil the movie for you guys, but there was a languages, like a person who studied language, who taught languages in the university. You know, they invited her to visit, and she said a quite interesting, I believe it was quite an interesting fact. So they said that the languages said that right at the beginning, when Captain James Cook, who first landed on, I think, you know, some part of Australia, and the men encounter a bunch of native Australian, the Aboriginal people, I would believe, and they said, and the point, the crews, Captain Cook's crew, point at one of the animal jumping around and ask the native people, "What is that?" And the Aboriginal replied, "Kangaroo." And that's how the name come from. But she said that actually means "I don't know, I can't understand" in the native language, native people's language. So the name kangaroos to the Aboriginals at that time, it just means "I don't know." I just thought that was interesting. I didn't know that. You know, after I watched the movie, then I found out that, and I was like, intriguing. Anyway, let's get back to the question. Okay, so find the rate of growth when t equal to 0, t equal to 5, and t equal to 40. Well, that's easy. We just sub them into the rate function. So p t is equal to 12. Now I'm not gonna go log e anymore. I'm just gonna go ln. All right, ln same as log e. T plus 1. All right. So therefore, if t is equal to 0, equal to 12 ln 0. All right. But I believe ln 0 is mass error. Oh no, sorry, no, it's not ln 0. Sorry, my bad. Yeah, it would be a mass error. 0 plus 1. Alright. So that will give us 12 ln 1. And log E1, ln 1 is just 1. I think just 0. This time is 0. Pretty sure. 0 is. So the rate will be 0. Right? So that just tells you at the beginning there's no growth rate. Of course, because this is right at the beginning. At that time, the rate is not increasing, all right, because it just started. So next, you know, when t becomes bigger than 0, you were expecting some growth rate. Okay, so next one is p bracket t 5 equals to 12 ln 5. Oh, the bracket shouldn't be here. The bracket should be inside that. ln 5 plus 1. So p 5 equal to 12 ln 6. Alright, I'm not gonna go find out what that is. I'm just gonna leave it like that. If you're interested, you can go find out you can write down the actual decimals. Okay, so the next one is pt40 is equal to 12 ln 40 plus 1 is equal to 12 ln 41. That's it. That's the rate of growth in the different years. Right? Okay, next question. Sketch the graph of p as a function of t. Alright, well, let me go to decimals. Oops, not you. Boom, there it is. So that's the graph, 12 ln bracket x plus 1. Okie dokie. Let's go to question C. Determine the inverse of function. p negative 1 bracket t. Alright, so we have to find the inverse. Alright, just let me write the function again here. Now, hopefully you guys still remember how to do the inverse of a function. Right. Let's just treat it as p instead of pt. Yeah, just treat it as p. Alright. Oh no, let's just put it as y. Alright. That this way makes it easier for you guys to remember, understand. Alright, so how we find the inverse of a function is we move everything from one side to the others. Alright, so we move everything on the x side to the y side. Alright, so that would first we move the 12, so it'll be y divided by 12 equal to ln x plus 1, and then we move the ln to the other side. Now when you move the ln to the other side, it becomes e to the power of y over 12 equals to x plus 1, and last bit you just move the 1 to the other side, give you minus 1, give you x. Alright, so once you finish moving everything from the x side to the y side, you change the x and the y's. So it becomes e to the power of x over 12 minus 1 equal y. And that is the inverse. This is the inverse. Alright, so that's the inverse. Okay, that's C. Alright, let's go D. Use the inverse function to assist in finding the area under the graph of p as a function of t between t equal to 0 to t equal to 40. So we got our two domain here, t equal to 10 and t equal to 40. Alright, so they said use the inverse function. Okay, let me just graph the inverse function on the same Cartesian plane and see would that help us. Boom, we're back. Okay, so we graphed it and doesn't really help because we are looking for from 0 to 40. Alright, so we're looking for now this function is the inverse, right? So we're looking for all this area. Well, I suppose you can find the area under this one, but you still need and then you find the area between these two curves. Alright, that's a bit troublesome. Why don't I just find it entirely just like that? Alright. Now, I don't think, when I go through year 12, right, I don't think I've ever learned this particular integration method. But right now, I know how to do this sort of questions now. So let me show you. And I'm going to make a special video, sometime in the future, just to explain the other different wonderful technique that you can use to integrate different functions. All right. But for now, just bear with me. So we are given, okay, well, let's go back to the question. We are supposed to use the inverse function to assist. Well, doesn't really help me. I don't know what to help you. It doesn't really help me that much. So finding the area under the curve of the growth function between t equal to 0 and t equal to 40. All right. So we are integrating between 40 and 0 of the growth function. The rate of growth function 12 ln t plus 1. Sorry, let's use x in this case. Now we can go t, doesn't matter, with respect to t. Alright. So that's our function. Okay, so let's go. So let me take 12 out of the integration. So because it's just a constant. Alright, so just ln t plus 1 dt. And then I'll let x equal to t plus 1. Therefore, if we differentiate x dt, I get so if I differentiate x with respect to t, I get just 1, right? So the derivative of t plus 1 is just 1. And then I move the dx, I move the dt to the other side, so 1 dt. Alright, 1 times dt, which is just dt. Okay. Now this process is this step is very crucial. So now our function becomes 12, 40, 0, and then ln no longer t plus 1 is x, right? Because x is equal to t plus 1, and dt is equal to dx, so with dx, right? Okay, dokie. Now, right now I'm going to use a method called integrate by part. All right. So the rule for the integrate by part is when you it is especially used to help you integrate when something times something. The function is something times something. Now you might see this is only just ln x. It's not something times something, but it is always, there's ones always there. So it's literally always 1 multiplied by ln x, right, dx, and that makes it something multiplied by something. So you can use this rule. So if because dash u dv is equal to u dash v minus integrating v du. All right. In this case, our 1 and ln x is over this side. All right. We have to decide which one is u, which one is v. And like I said, I will make another. I will make another video to explain this further, but right now I'm just going to finish the question, and I will choose well, I will let u equal to ln x, right? So when we differentiate, then when I du dx, when I differentiate u with respect to x, so this side will become 1 over x, because that's what happened when you derive ln x, becomes 1 over x. All right. So we then, since ln x is u, then whatever left in here, which is integrate 1 with respect to dv, is equal to 1. Right. So whatever left in there, in here, is this. You know, once you take the u out, that's what is left in there. So now you're integrating 1 with respect to v, you get v. And you integrating 1 with respect to x, you get x. All right, because this is usually because it's very hard to explain right now, but you know, that's just what it is. I'm sorry guys, but yeah. So we remember, so now we have to integrate 1 ln x, which is what we want, is equal to, remember, u times v, our u is here, our v is here, so u times v is just x multiplied by ln x, right, minus integrate v, which is x, with respect to du. Now du is just 1 over x multiplied by dx. Right, so this is du. So we just substitute it here, multiplied by 1 over x dx. And we get, so x ln x is here, minus, now we can multiply it, and this one actually cancels out, alright? It becomes 1 dx. And 1 dx we can do, certainly we can do that. Alright, and that just become x. And then we put the big plus c at the end, the cool guys. And that's it. And that's the integral of 1 ln x, or you can call it just ln x. Alright, we just found that. But look, we didn't start with x, remember? We started with t. Alright, so x is equal to t plus 1. So we sub everything back. Sub t plus 1 back into x. So it's actually equal to t plus 1 ln t plus 1 minus t plus 1 plus c. Right? Oh no, there's no plus c. I forgot, guys. This is a definite integral. I just didn't write the integral. See, it's very important to keep writing your the integrals domain, this is actually 40 over 0. Remember, there's no c here. There's no c here. But we still have to sub it back. We still have to sub back the t plus 1 in, that's for sure. So we got the integration, which is x ln x minus x over 40, 0. Alright? And then we have to sub the t back in. T plus 1 back in. Minus t plus 1. Alright? And we can factorize it a bit inside to make it look better. So it becomes, take the t plus 1 out. And then multiply by ln x minus 1. No more ln x. No more ln x. T plus 1 plus 1. 40, 0. There's no more ln x here as well. So there's minus 1 in here, sorry. Making all this silly mistake. Okay. Alright, finally we can sub the numbers in. 40 plus 1 multiplied by ln 40 plus 1 minus 1 minus 0 plus 1 multiplied by ln 0 plus 1 minus 1. Rightio. So that we get 41 multiplied by ln 41 minus 1. Alright. And then minus 0 plus 1 is 1 multiplied by ln 0 plus 1 is 1, so ln 1 is 0, remember? Minus 1. Okay. So that gives you, now let's just expand this into them. So we get 41 ln 41 minus 41. Alright, so 41 times negative 1 is minus 41. Minus 1 times negative 1. Right? And that will equal to 41 ln 41 minus 41 minus negative 1. And that would just give you 41 ln 41 minus 40. Right, because negative 1 minus negative 1 is plus 1. So it's negative 40. So that is area under curve. That's the total area under the curve of the growth rate function. All right. Last, okay, so what can we give you unit areas? So which tells you the next question. What does this area represent? So if we can answer the last question, we can answer this question. We can answer the unit for this one, right? So remember, the growth rate function at the beginning is a derivative, right? It's a rate function. It's a derivative. So that must be, it must be dp over dt equal to growth rate. The rate function, sorry, the rate of growth, right? And we know that's equal to 12 ln t plus 1, right? That's the rate of growth function. And when we integrated it, we moved the dp to the other side. So give us dp equal to 12 ln t plus 1. I just realized something. I forgot to times 12 right at the beginning. The 12. But I can suppose I can still times 12 right at the end. Alright. So 41 times 12 492 ln 41 minus 40 times 21. That's 12. 480. Let's see what that gives us. Let me calculate the number out this time. So 492 ln 41 minus 480. I get 1347. That's the number. Whew, I think that is still the right answer, so nothing goes wrong. Okay, remember, please remember, you have to, don't forget whatever constant we took at the beginning. Please don't forget that. Don't make the same mistake as I did, alright? But hey, I didn't make a mistake. I realized it, alright, before. I realized it when I see the DP here, DP equal to 12. I said, the 12 is missing somewhere. But anyway, 1347 is still the right answer, I think. Okay, go back to there. So what does the answer represent? We integrated that. We integrated the growth rate function with respect to the t. Alright? So, whatever. So remember, when we integrate both sides. So what this side becomes, this side is actually population. Right? So the rate function, the rate of growth is population over time. So when you integrate the function with respect to t, the time factor is gone. Whatever left is the population. So the population is equal to the integrate of 12 ln t plus 1 dt. So what we get is actually the population. So therefore, we can write the unit for the previous answer. So it's 1347 kangaroo. Because it's a kangaroo population. Kangaroos. So therefore, the area, AUC, area under curve, of the growth, rate of growth function, function between t equal to 0 and 2 to t equal to 40 is the total population of kangaroo. I don't know. Who's between so the starting of the time is 1st of January 1955. So 1st of January 1955. So between 1st January 1955, which is t equal to 0. Between 1st and 1st of January 40 years later would be 1995, where's t equal to 40. So between, yep, that's it. That's the answer. All right. So there's 1347 I don't knows between 0 to 40 years. In 40 years time. So okie dokie. That's it. That's the last question. Finally. Even though I have to use... Look, I just couldn't see how the inverse function would help me finding the area under the curve of the growth rate function. So yeah, I used a method that I've learned. You know, I'm pretty sure I didn't learn it in year 12, but I used the method that I learned later on, you know, which makes me like integral even more because I got more I got more method to handle questions like, you know, different type of questions. So, yeah, that's how I use the integration by part to solve. And yep, and that's it. That's the last question. It's been a long journey. All right, then. I will take a short commercial break. Now, this time, sorry, it wouldn't be a short commercial break. It would be a rather long break. And then I will continue with chapter 9. Yeah, chapter 9. Keep going. All right, see you then.